Okay, sorry, I missed a little bit of the lecture here, but let's just at least flip over the slides and see what was shown here. That's one second. I got a screen share. 1, 2, 3. There we are. Share. Okay, so sorry for those who were relying on the recording, but basically I forgot to start it, and I will try not to let that happen again. But basically, we started out with what a data model is, mathematical representation. First, it consists of representations going to be manipulated or going to hold the state of the database, the operations on the data, which is going to be kind of the language operations, and then the constraints, which basically say that certain combinations are ruled out by definition, like a primary key constraint will rule out certain representations. Then we're just going to go through what a table is, and then the data. So there's the table, and then the database schema. This is where I'm going to leave off, resume again. The database schema is a set of the tables, the definitions of the tables, not the actual state of the tables. Okay, so when I talk about the state of the table or the database state, we're talking about the whole, like all the tuples or all the rows. Okay, so that's kind of just some definition stuff. So why relations? Okay, it's a very simple model. This model is extremely simple. Whether or not it matches how we think about stuff, well, maybe. And this is the model that underlies SQL. So some people are like, well, they're like, why is it? I mean, it's so simple, but that simplicity winds up being a virtue because there's so much complexity when you start modeling things that it's nice to have a simple base or a simple data model to work from. Okay, so this has kind of stood the test of time in the sense that people understand the virtues of having an extremely simple model. Okay, so here's our running example we're going to use. And just as a disclaimer, well, I'm taking this from the Stanford textbook and all that, but I mean, just we all know that this shouldn't be taken lightly. I mean, it's fun to talk about drinking and all that, but there's a lot of people who died because they drank too much. Okay, I just want to make a little disclaimer there. I'm not trying to promote that. Oh, it's just there I have a table called has drinking problem. Yeah, let's keep that in mind. Okay, but anyways, let's back to the example here. We have the notion of beers, bars that serve beers, drinkers. These are people who drink beers. Drinkers like a beer. All right, so this is a relationship between a drinker and a beer, right? Likes. Sells, that's a relationship between a bar and a beer. A bar is selling a beer at a price, okay? Frequents is that does a certain drinker visit a certain bar, okay? So the drinker visits a bar, all right. Has drinking problem is also a table, which is basically has the name of the drinker who has a problem. All right, so the normal convention is you underline the primary keys. So basically what the primary key basically says then is that for each bar, every bar has a unique name. So you don't have two bars both named Rex, all right? So you might say, well, but we want to allow for that, right? Especially in a big city or something. Well, you could allow for that if you added another attribute here called ID, which was an integer, and therefore you could actually allow for, and that would be the primary key, and you could allow for the name to duplicate, right? So that's an issue of like, there's an issue here of like, well, what is it mathematically, the structure and all that? Now, these are these tables. And then there's a question of what are you really, what is the reality you're trying to model, right? And if there's a mismatch, the requirements of the application mismatch the capacity of your model to model that reality, then you're going to have a problem, all right? So that has to do with kind of this design stuff. All right, so this is an example of a constraint. Of course, these primary keys are an example of a constraint, okay? So now let's just look at SQL for a second because I want to give you something to kind of play with here. As far as SQL goes, this is just kind of just saying kind of what it is in just kind of an informal, just kind of writing it down as a notation. But SQL, in addition to having queries, you can also define the databases. So the simplest form. So basically, we're gonna show how we would define a database like this in SQL. So the simplest form is just to basically create a table and then give the table a name, and then we have a list of elements. Okay. You can also drop a table, by the way, as well. So the elements of the table definition are usually just, well, they're an attribute and its type. So it's integer, real, character, varchar. So here's an example here, finally getting to it, of the idea of creating the table cells. So a bar, which has, the type is a character, so you can have up to 20 characters in the name of the bar. And then a beer, again, likewise, you can have up to 20 characters. There's a slight variation, slight difference here between char and varchar. We won't get into that at this point, but we'll talk about it later. And then price, which is going to be a real number. All right. All right. So once you define this table, then you can actually start adding rows to it. Okay. So integers and reals. So the way the types work in SQL is fairly straightforward. Integers and reals are what you expect. You denote strings with quotes, with single quotes. Okay. And if you need to have a quote inside of a string, you do a double quote. It's kind of old. This is really kind of an old style of doing things. I mean, if people could redesign SQL from the ground up now, they probably wouldn't do it this way. This is not so modern. Any value can be a null. So null is that special thing we talked about before. Dates and times, they have a literal value in the database of having date and then this format here. So what's nice about this format, by the way, 2007 0930. Why do we represent it that way? Can anybody think? Why would we represent it that way as opposed to maybe like, we could do like the American way, which is crazy, and that is that you put the month, like it'd be in American, it would be 9/30/2007. Well, I don't know if people have seen that before, but that's the way we have a convention in America that is based on the day, then the month number, the month, and then the day, and then the year. But why would we do it this way? Why having 2007 up front and then 09/30? Anybody want to say that? It's easier to sort by date. Correct. Yes, exactly. So what's lexicographical ordering? So when you do the ordering basically on just like the alphabetization ordering, in this case, alphabetization ordering corresponds with the date ordering, right? So that's why you need to have a 0 in front of that 9, right? If you had just a 9 there, then it would be bad. It would screw up the ordering, all right? So there's that's the reason why they do it. Okay, time, you can also put in timestamps. So, or here's the time, and together they become a timestamp. So the date and plus a time is down to the timestamp. Okay, declaring keys. All right, so now we'll get to something maybe you should learn something here. The attribute, when we declare the primary key, it can be an attribute or a list of attributes. So you can have them multiple ones. Basically what it says that no two tuples in the relation may agree on all of the attributes on the list, right? If they're two distinct tuples. And then the question is, so we see right here, we're declaring right here, primary key or unique. So you can say unique or primary key. So unique does the same thing, but we'll talk about the difference in a second here. So this right here basically says that each tuple is going to get a unique name, right? Now, we can make this with more than one attribute. So if we say right here, and this is the way we would want to do it, in fact, we would want to say that that when we're talking about selling, it's the primary key actually winds up being a combination of the bar and the beer, right? And those have a unique price. So for every bar and beer, there's one single price that you're gonna record. So the idea here that if you made the primary key bar, that would screw everything up, because then you would have something like if the primary key here for cells here was just bar, what would happen? That would mean that I could have the bar of Rex. Okay, that would determine, that would basically kind of screw things up, right? If I say that the bar is the primary key of cells, that means that a bar can only sell one type of beer, period. People see that? All right, so I'm does anybody want me to repeat that? Or does anybody understand why that? Okay, good. Some people, if anybody wants, yeah, okay. So if I had said that the primary key was bar, then what a primary key literally means, it means that two distinct tuples, there can be no two distinct tuples that share the same value for that. So basically what that says, I can put one tuple in for Rex. So Rex can only sell one beer. So that's not good, right? If I put in just beer, then likewise, beers can only be sold at one bar. That'd be crazy. Okay, so if I have them both in there, though, that allows me to have all the beer bar combinations, right? But they can only be sold because these are the primary key. They can only be sold for a single price, all right? So the price has to be the same, right? So I can only have one tuple for like Rex and Prips Blow, and I can't have two tuples for that, right? Rex and because that's the key. The key is Rex and Prips Blow. So that means that I can only have one price for Prips Blow, all right? Now you might say, well, actually the price of Prips Blow goes up and down based on what night it is at Rex. That would mean that you would need to add another attribute here called like the day of the week or something. And then that would the bar, beer, and day of the week would wind up being the key, all right? So there's some subtleties here, and there's some kind of modeling issues about what you decide as the primary key, all right? I hope that made sense. If it doesn't make sense
now, vad som kom? Jättebra.
Finns en fråga? Eller? Okay, good. Oh, yeah. Okay. So char basically it's a physical thing. It has to do with how it's being represented in the database. Varchar basically what allows for you to do. Strictly speaking, these are kind of the same in most implementations. So I just use varchar as a matter of practice. So varchar just means that it's a variable. It could be variable length. So if you say varchar 500, but you only use 3 or 4 characters, then in principle the database can compactify it down to just 3 or 4 characters. Okay, but see them as the same. In fact, if I was going to re-edit this thing, I would make it just varchar. Okay, primary key versus unique. Okay, so there can only be one primary key for a relation, but several unique attributes. Okay, all right. So what does unique mean? Unfortunately, I don't have much of it. I had this. All right. So, gosh, I mean, should I risk it? I don't know. I mean, we'll get to unique later, but let me just say it verbally here, what unique is about. Let's say that you had a relation that was person, and it had the person ID, and we make the person ID the primary key, okay? So the person number is the primary key. Okay, but let's say I have the attribute email associated with the person as well. I think it's pretty safe to bet that those are unique, right? So in other words, do 2 people share the same email? Okay, maybe, but let's not get into that possibility. Let's just say that everybody's kind of, having their own email. Or you could say something like this. What about driver's license number? Now, I guess in Sweden, is it true that your driver's license number is your personal number? Well, in America, it isn't. You get this other crazy code for your driver's license number, but that's going to be unique. But it's not the primary key. The primary key in America, at least, is a social security number. So you have these other kind of attributes that are kind of hanging out that also that have to be unique, but they're not the primary key. All right. So so maybe like something like phone number might wind up being unique, or we'll come up with a lot of examples where you're going to see that we need to have unique. Yeah, but that was just kind of your crash course in kind of SQL type stuff and as a data model. All right, so so we'll get back to unique. If you don't worry, we'll talk a lot about unique later. All right, so semi-structure. So that was the relational model. So now let's talk a little bit about the semi-structure model, which is kind of the main alternative to the relational model. So there's another one that's based on basically graphs or trees. And the motivation for this is that as opposed to the relational model where you're setting up these tables and you're declaring upfront what the attributes are, the advantage of the semi-structured model is that you just let people define it as they go along. And I'll show what we mean by that in a second here. So it's kind of like basically what we have is we basically have a graph. And maybe now I will do this. Yeah, I'm going to do this. How am I going to do this? Sorry guys, I'm going to do this later on when the problem is that I have a little bit of a problem with getting the software set up for this scribble pad. So we're going to have to wait on this. Sorry. I'm just going to have to do it verbally in this first lecture. back to this. The page maybe? No, I have to do this. Go back to the presentation. You know, you would think I have this worked out, right? There we are. So, okay, so let's think about this following way. So we have, I mean, everybody knows what a graph is, right? I mean, your V, I mean, what is it? I mean, a graph, G equals VE, right? So G equals vertices and edges, okay? Now, let's assume that we have a graph and you basically are gonna put labels on the edges, all right? You can name them whatever you want, okay? I tell you, you can name them whatever you want. And the nodes or the vertices are gonna represent objects or things, all right? And then there's gonna be leaf nodes that are just gonna be atomic values. So there's no arc going on, it's just kind of like, just a value at the end of it. Okay, so if I had the scribble pad working, I would write down like one node, and it doesn't really matter what identifier that node gets, but then I would have an arc pointing out from it, and the arc would be labeled with name, and then there would be an atomic value, Michael, and that's me, right? And then I would go back to that same vertex, and I would point it out, and I would point it to something like nationality. Okay, so I would point to America, USA. I'll make another node, USA. I'll point to nationality, and then I would say, okay, and then I would link from Michael to that node. Okay, and then I can also make another edge, and then I would point to a fresh node that says that was basically boat, or it was like the name of a boat, and then it would say has on the edge. So, and then I might also, I don't have a dog, but I could easily put a dog in there as well, and I could just start kind of linking this thing up willy-nilly. You get the point? So like, if I told all of you guys right now, I want you to like grab out a sheet of paper, put like a node in the middle, and that node, give that node, call it N45 or something, or whatever you want to call it, and then create another atomic value called whatever your name is, and create an edge that points from that node and out to that value called name, and then start just kind of willy-nilly adding, like you might have like the hobby of like watercolors, and so you could like put in edges that basically point out, you know, the label of the edge is called hobby, and it points to a node then there's another link that goes out from that called is watercoloring. You know, I mean, you guys get the idea. You could just kind of start building out this graph with all these kind of names floating around, and nobody is sitting there and going to police you about it. The data model is very simple. It's just a graph with like labeled edges and nodes that might have edges going out, or nodes that are just atomic values. Does that make sense? I mean, can you see doing that? I mean, it wouldn't be that hard, right? I mean, you could just do that, and you could keep on doing that, and just without any discipline at all, just start filling up the whole piece of paper, and then grab another piece of paper, and then just kind of keep on doing that, right? Now, it's kind of in a way, and then what you could do, if we came up with like a format you're supposed to put these in, you could then send all of these to me, right? And then I could do an operation where I say, all of you are in the database course. And then I can, of course, make a little graph about the database course where it points off and it's part of Umeo University's course offerings and blah, blah, blah. And I'm the teacher and class is the assistant. I could just keep on doing this, right? And if I had you guys do this in some kind of format, right? So okay, you writing this graph on a piece of paper is kind of useless, because what am I going to do with that, right? But I say, instead, I want you guys to encode this in some kind of flexible format, and I want you to send it to me. I'm going to put all these things together, right? And I don't know what kind of labels you're using. What I'll do then is I'll basically chase the labels, and I'll say, I want to find out all the people who have a dog. And what I'll do is I'll basically say, I'll visit the students, like all the student nodes that are a member of the database course, and then I'll look for all the variations, has pet, pet, what are all the possible variations that you guys use to plug in your dogs. All right. So, but you get the idea. I mean, I could do that. And then I could start asking queries of like, okay, give me all the names of the dogs of the people, of the students who are in the database course. Right. Now, it's a little bit sloppy doppy. There's no doubt about that. But can you see me kind of doing this? I mean, you know, who wants to be that accurate anyways? I mean, it's kind of going to work, right? I mean, there's some value in it. Okay, so that's the idea of semi-structured. Okay, so if we want to find a specific person, yeah. I mean, you just kind of slop around, you know, it's like, I told everybody to send me in the thing, right? And then I wrote a little routine that basically patched it into the database course. So I can then kind of do like the back pointer and find out all. And I told all of you guys to make yourself the root. So I should be able to get all the people. Yeah, we could like get we could visualize it. We could try that. But the thing is, if I have like, let's say I have over 100 people who do this. I mean, the thing about it is that maybe what I would want to do is to say, hey guys, could you please just consistently, I want to get all your dogs, but you know, could you please like, could we have some kind of language? Could we have at least some type of structure to this thing so that you guys aren't just going to just, you know, pull any kind of name out of thin air to label a pet, right? Okay, so what we're dealing with here is we're dealing with like kind of something that's not, it's definitely not structured like a relational database anymore. It's pretty sloppy, but there might be uses for this kind of thing. There might be uses. I mean, the nice thing about it is I let you guys be creative, right? I just say, just do it, right? We don't have to go and like hire consultants to kind of figure out what the model is, right? We just go ahead and do it, right? So anyways, that's the kind of the spirit, at least, behind the semi-structured data model, which is based on a graph, essentially. Okay, so here's an example of one of these data graphs here. And as we'll see, basically that, I mean, how many of you guys have heard of XML? I'm sure that you all have, right? I mean, yeah, XML is essentially the basis of semi-structured, right? So it's actually, the truth is it's more of a tree than a graph, but with these back pointers and with some of the other stuff, you can kind of get a graph out of it, but it's still a little strange. But basically, XML becomes the basis of the semi-structured data model. Now, in more modern times now, JSON I mean, I'm sure you guys have all heard of JSON. JSON. Okay, JSON. JSON is now a bit more popular because it's a little bit cleaner than XML. You know, when you talk about JSON and this kind of way of doing things, it's still kind of the same spirit, though. It's kind of, you know, it's not as structured as, it's not table based. It's more tree based. Okay. And by the way, if people heard of MongoDB, which Combro is based on. So Mongo is using JSON essentially. Okay. So anyways, with XML, what you get is you get some kind of semi-structure. This is why it's called semi-structuring. Well, you know, what's an alternative here? I just want to, this is kind of beyond the scope of databases, but here's another alternative. Okay. And this is what we would call a no structure. I just say, hey, everybody, could you guys just type up 3 paragraphs or 4 paragraphs, whatever, just type up a description of yourself in natural language. Okay. And then you send those to me. Okay. Now how am I going to search that? I have to do like keyword searches on that. So just to kind of complete the picture here, we have structured, which is like table-based. We have semi-structured, which is kind of XML graph-based. And then we have no structure, which is just give me a block of text. All right. So these are the 3 options, essentially. Is there another option? No, those are the 3. There's really, I mean, when it comes down to it, those are the 3. I don't know. I mean, if someone can come up with like another one that's another option in terms of representing data, let me know. I mean, but you know, can be structured however you want, but you need to know how it's been structured in order to properly parse it. Yeah, so that's right. Yeah, so that's exactly right, Ludwig. And we'll cover this right here. It's like this is why it's called semi-structured. It's not as tightly structured as a database, as a relational database, but there is some structuring. And if we look at it right here, and because of that structuring, we can do parsing. And then later on, we can actually query these things. There are query languages namely XPath and XQuery, which we're going to cover in this course. So you can wind up searching these things and querying them. Okay, so just to do this quickly, well, I mean, a lot of you guys have seen this stuff before, of course, with XML, but you have the notion of a tag, and the tags have to be balanced. So if I just take a bunch of tags and I kind of just like, throw them together in kind of a random ordering, then it's probably not going to be legal XML. So the first question always is it valid or invalid XML? And it's very easy to make invalid XML if you don't balance your tags, right? Okay, so when I tell you guys, I want like this description in XML of each of you and all that, you got to balance your tags, right? You can send that through like just a simple validator to make sure it's going to work, that you're at least doing that. All right, so here we are. Bars. Okay, so here's an example of representing the bars here, where we have bars, we have Joe's bar. These are all just kind of nesting things inside of tags. All right, so as we know, if you've done anything with XML, and it's and HTML, which is not quite XML, but anyways, you get attributes. So you can go and you can do this thing right where you say basically an attribute. So a bar, instead of having Joe's bar as kind of an internal kind of printable character data here, what we're going to have is we're going to have it as an attribute instead. Maybe it's a little more structured. You can sit there and say the bar's name is Joe's bar, right? And based on this, well, there can only be one name of the bar, right? Because attributes can't duplicate. You can't have name Joe's bar and then name Sally's bar, because name is already occupied in the tag. All right. Likewise, price and this stuff right here. So you have you can do it this way here. So now you can just go and do these things, and that will give you like, this is like basically standalone XML, and that's all fine. You can use these tools with the standalone XML. But if you want to put a little more structure in, what you can do is you can make what's called a document type definition. So this kind of gives you a little bit more structuring over the way things are kind of built up inside the actual XML document. So I'm assuming a lot of you guys have seen this kind of stuff before. So the idea then is that from the root level of bars here, you're going to have each bar listed individually. This is the Cleany star, which means zero or more, zero or infinite number of. And the bars then have a name here, which winds up becoming an element. And you can also put attributes in here. So you can have the attribute lists, which constrain now what winds up being illegal, or it's putting a little more structure, but it's not putting as much structure as, say, a relational database over things. Okay, so that was just kind of like a little bit of a taste of kind of what the what semi-structured databases look like. So you have a little bit of taste of what structured database look like, and a little bit of taste of what semi-structured looks like. And then no structure is just kind of like a big blob of text. Although people can argue and they can say, well, actually, even no structures have structure, because we have the kind of notion of topic paragraph. We have the introductory paragraph, the thesis paragraph, and the conclusion paragraph or something. So there's a little bit of implicit structure there, but generally speaking, I mean, we call it no structure, and we just have text. Okay. All right. So the last thing I just want to say here is just to kind of get everybody kind of motivated here, and that is that database course. I mean, I know you guys all come from a lot of different backgrounds, and I mean, you have different ideas of what you want to do with your lives and stuff like that. But I want to say that databases, no matter who you are, databases are of value to you. So there's a good reason to pay attention to the course and to really kind of geek out on databases. And one of them would be this. Okay, so one possibility is you like working with systems. So you like kind of setting up big systems that are doing kind of important things, and then you like to tinker with them and kind of configure them and make them run better. That's kind of what you like to do. Well, databases are really kind of big, complicated systems. And the one thing is that the database system we're going to use in this course is PostgreSQL. And you'll be happy to hear that PostgreSQL is really going like gangbusters in industry now. So it's lots of people are using PostgreSQL. I mean, there's a lot of other database systems out there too. There's one that's really interesting. I'm not sure how many people have heard of it. Probably nobody, but maybe you will. But have people heard of CockroachDB? So CockroachDB is pretty cool, actually. It's look up CockroachDB. That's I think it's going to be a big thing. So if you like working with, it's like a distributed relational database, SQL database, and they're I don't know. I mean, they've got a lot of investors now. I'm not really sure, how they're going to make money, but yeah, that's another issue. All right. So anyways, if you like working with systems, databases are for you. There's like big, complicated systems. And, I like to tell people like this. I'd say like, if the Matrix ever happens, the Matrix, I don't know if maybe you guys are a little bit too young to have seen the Matrix film, but the Matrix, right? The whole kind of setting that whole thing up. Yeah, good. I mean, of course, everybody's seen the Matrix. I mean, that was a database, all right? There's no doubt about it. I mean, that was a database. It was defined as a database logically. It wasn't a whole bunch of little programs running around, or if they were stored procedures, but the whole thing is a database, okay? That's how they get that thing to work. There's no other way you can manage that thing. Matrix. The Matrix is a database, all right? It's a relational database. And I'm saying it's a relational database and it's based on SQL, all right? There's how else would you get that thing to work? The only way you could get that thing to work is if it was an SQL database, all right? So I'm going to make that as a claim. All right. Okay. Anyways, let's say that systems are kind of like, that seems like a lot of work. You don't want to do it, but you like theory. You like stuff that's kind of like mathematically deep, and this seems to be kind of fundamental things going on. Well, logic is pretty deep, and databases are based on logic. So, and there's some other kind of theoretical aspects that come into databases as well, like concurrency control, transactions, this kind of stuff. So it's a lot of theoreticians have really kind of feasted on the whole database concept. Okay, so it's deep in that sense. All right, well, things you might say, I don't really like systems. I like working with people. Well, everybody's got to work with the database, right? I mean, there's like the whole thing about that is that you got to like, if you want to work with people with respect to databases, is you got to like, it takes a certain social skill, which I don't have, by the way. Well, maybe I do. I don't know. It takes a certain social skill to kind of elicit kind of what people really want to model in the system, right? Because they get really annoyed once you start kind of really, at least with me, they do. Because I start kind of like trying to nail them down on what they really are representing, because they got to get the model. You've got to get the model right. So someone that has a bit more kind of finesse would probably do a lot better job than me, because I would just barrel in, and they would either think they were an idiot or they would think I was an idiot, because I would be sitting there saying, well, no, exactly. I was trying to get I'll try to get them all. When we get the conceptual modeling and the ER diagrams, stuff like that, you'll see what I mean by this. Okay, so if you want to work with people, that's databases are for you in that regard, to kind of list the models. If you want cash, big money, there's a lot of money in it, actually. Because I mean, this is like, they say this is like, data is like the foundation of society and all that now and all that. I mean, doing a startup in the database area, you can make money. Okay. Yeah. I mean, there's a lot of money there. Okay. They say, no, look, I want to work in, and name the area. I want to work in, you name an industry. I want to work in the entertainment industry. Okay. I want to work in, rocketry. Right? I want to work in the space industry. I want to work in, whatever it might be. Getting like, you can get in by being the database person. So you can pick a domain, because everybody uses databases in all branches of human activity. Everything. You say, I want to get into nonprofits. I want to get into like poverty programs, in certain areas. Well, I mean, I don't know. Maybe it's not the most efficient way of getting into that kind of stuff, but you could probably. They need to get their database working. I mean, and they need to model things right. So so there you go. Okay, and then finally at the end of this, you might just say, Michael, come on, bug off. I mean, you're a little bit heavy here with all this kind of ambitious stuff. Forget that. I just want a 9-to-5 job with benefits, so I can enjoy my life and do my hobbies and not be all stressed out by achieving something. Well, with a database and database knowledge, you can get yourself a 9-to-5 job. And you can get a job that with benefits because you're performing kind of a critical function, and you become indispensable, and and you can draw a salary. So yeah. So I'm not sure if somebody said, I don't want to do anything. I don't know. So I don't know. You don't do anything. Well, anyways. How much experience do you need to work with databases? Not too much, really. I mean, you need to start out small. Start out with, just do like baby steps, and then next thing you know, you're up and running. I mean, after the end of this course, I mean, you should be, if you say by the end of this course, please don't quote me on this, although it's being recorded. if you say, by the end of this course, screw everything. I want to get just like leave the university and go out and get a job. Well, I don't know, maybe with the database knowledge that you're going to get in this course, you could probably start doing like contracts and stuff. I mean, but I'm not suggesting you do that. Stay in school. but still, yeah, with database, I mean, yeah, I mean, it's, I mean, somebody might say, oh, well, AI is going to come along and then like replace all the database people. And I'm thinking, I don't think so. One of the last, that's a real tough problem to have. It's going to be, that'd be really tough to automate, to have AI do the database stuff. No, I mean, and I can, maybe we can discuss that as the course goes along, why that would be very, very difficult. It's not like pattern matching, you know, it's not like just recognizing, is that a hammer or is that, you know, a car coming. It's deeper than that because you have to do the design, right? And everything's changing and shifting, and it takes a certain amount of insight, which AI programs frankly don't have. So, okay. Anyways, I hope that motivates you guys at least. And then, you know, the next lecture we're gonna start. You know, we're gonna start getting into this relational algebra calculus because I need to kind of get that presented enough, because then your first recitation is not this Thursday, but the following Thursday after that. And I always try to give you a week to work on the recitation. So so when we cover the relational algebra and tuple calculus the next time, that'll be enough for you to do the first recitation. Okay, so are there any questions or no, you can just basically pick either class or myself. I suppose if everybody goes to class, because I'm assuming that would, you know, let's be honest here. I mean, if that happens, it'll probably be everybody goes to class. Then I'll basically say class, because you send some people over. I mean, but it's not going to happen. It never happens. I mean, they tend to kind of even themselves out. So just pick which one you want. Yeah. Sorry, there are pages to read today. So consult the readings. So yeah, best that you get. I mean, start doing all the readings. I mean, you know, right now, better to kind of get it done and then hear me talk about it rather than, you know. So the lab reviews, that is up to class more how they're going to work. But my understanding is that, well, because it's new now, because we're doing everything over. It used to be different, but now it's because of the COVID times. What you're going to wind up doing? No, there's no handwriting on Thursday. This Thursday, we're waiting to get that removed. The way it works is that basically you tell him through some queue system or whatever that that you're done with the lab, you and your partner or you alone, and then he says okay then, and then he talks to you, and then you got to show that you are done, and then he checks you off as being done, or he says no, you got to fix that. Let's see, is that how he wanted to work it? It's up to class. I mean, class is he's going to work that. I think it actually makes more sense. I'm not really sure if he'll do that for the first labs, but the second lab definitely. That's the one where you guys are going to define your own database, and you're going to make a CRUD application over that. So yeah, but that'll come out. I mean, labs are going to be a little delayed. First, we're going to kind of do more of this kind of theoretical stuff, and then we're going to get into then more into the labs and SQL. Any more questions? Okay, I'm going to assume that's that, and yeah, I mean, you can always ask questions in the beginning and the end. And, okay, great. Yeah, I think it worked fairly well. I need to get better with the scribble board though, and also, yeah, well, I don't know. I hate wasting time. So, I mean, I'll set it up better this next time. Okay, catch you guys later. Au revoir. Stop recording.